headquartered in Lakeland, Florida, just an hour away. His team is responsible for incident response and what they term threat detection engineering. This requires the blue team to understand both the attacks and the systems they target. This method ensures that they have the right logs with the right analytics to identify attacker behavior. Previously, he was an officer in the U.S. Coast Guard and acted in various roles from escorting nuclear submarines to IT management at the Coast Guard Academy. Dan also teaches cybersecurity courses as an adjunct at Florida Southern College. He holds several industry certifications, such as the GIAC Certified Forensic Analyst.
Morning, everybody. Bridget, thank you so much. So, quick show of hands, who uses Splunk? So awesome, about half of you. Half of you will be really comfortable with a lot of my screenshots because I use Splunk. And I gave this talk at the Splunk conference just this past year. But I don't work for Splunk. I don't have stock in Splunk. And what I'm going to talk about actually has nothing to do with Splunk. It's just regular expressions. So the nature of this is that while I work for Publix, I'm not officially representing Publix, so I'm not even allowed to use the logo today. But my point is, I work for a grocery store chain. I don't work for a security vendor. I've got nothing that I could possibly convince you guys to buy at 11 in the morning on a wonderful Saturday. But we're going to talk about regular expressions today. So regular expressions are an engine for doing crazy cool wildcard searches. So show of hand who at least knows what regular expressions are. Everybody, awesome. Who thinks they're an expert in regular expressions? One or two, awesome. So the experts, I'm going to ask you to bear with me because I'm going to ask you to tone it down. And the reason for that is everybody else isn't. But you need to work with them, and that means the elements that you write, the regular expressions and the searches that you create need to be capable for everyone else on your team. So we're going to talk through some of the prerequisite knowledge to get through this. I'll walk you through some of the regular expressions to make sure everybody understands what we're doing. The philosophy that we developed at Publix, and just ways to develop regular expressions, good enough regular expressions faster. We're going to work through some common use cases, work around parsing errors, SQL injection example, cross-site scripting example, and Sysmon example. So, these prerequisites. IP address. We don't need something fancy, right? /D meaning a digit. 1,3, have that digit repeat 1 to 3 times. /period means I want the literal period. Everybody tracking with me? Pretty easy, right? Field extraction. This is probably the most important part of the talk. If you use Splunk, you love field extractions. This also applies with tools online. You can do this with, I believe, even Notepad++. The point is, you're going to capture elements with the regular expression, and you're going to pull it out into a field that you can now act on. And then there's just all the different character classes. These are good to know. A character class means the lowercase s is give me white space characters, non-word characters. The uppercase S, the exact opposite. Same with the D, digits, but an uppercase D, anything that's not a digit. So we're going to use this opposite concept throughout the presentation. And finally, what I'm presenting is not the only way to do this. I'm not saying that this is the Bible of RegEx, not by any means. But this will help you go faster with your incident response. Now, some of the things here is, if you're, yes sir?
Is this deck available outside of this, or do I need to take notes?
It is available, so it's actually been posted on the Splunk conference website, and BSides is recording the talk, so you'll have access to it. So yeah, now if you want to take pictures, be my guest. So this is after the alert. A lot of people who are used to working in a SIM, they're trying to craft this alert to be as precise and as accurate as possible. This is after that. You know something's happened. Now you need to collect all the data, which means you need to be fast. You are in IR mode. So speed over precision. That means it's actually okay to bring in some false positive data. Because we're analysts, we know what we're looking at. False negatives, however, are not okay. What I mean by false negatives are, I've missed critical data. My regular expression has not brought in the data I need to make a sound decision. Now, the experts in the room, they may like to write things like this. Mind you, this is 20%. Just 20% of the regular expression that we pulled off of Stack Overflow to validate RFC 822 email addresses. You know, sometimes you get so preoccupied with whether or not you can, you don't stop to think if you should. So I'm going to urge you to avoid the threat, click, of the Tyrannosaurus Rex. All right, jokes aside. So, which of these is easier to understand? They're both attempting to extract an email address. And depending on the data set you're working with, both of them can work. If the second one works, use the second one. Just worry about getting the data. So, which of these is easier to understand? Now, unlike the previous example, this one's more specific, but if the nature of your incident allows you to be more specific, choose the more specific example. Choose that Microsoft generic domain if those are the email addresses you're worried about extracting. This type of self-contextualization, self-documentation of the incident can make it much easier for the other incident responders to follow your footsteps to see how you did your investigation. And this is what I mean about good enough. So you might have brought in some false positive data. Obviously that middle one's a phone number. So what? You're an analyst. Remove it. Big deal. You don't need to make this perfect. By the way, this was Stack Overflow's suggestion. Which do you want to deal with when you're trying to review somebody's regular expression? All right, so good enough, regular expressions faster. So we've got a process here, and it's pretty straightforward, but unless you've been working in this in a while, you just may not have thought about it. First, identify anchors. So what I mean by anchors are, these are those character sets that are just not going to change around the field. They may be before, they may be after. So in the top example, I just want the domain. So my front anchor are going to be the HTTP : and the back anchor is going to be that /. Now, I could just make the front anchor just these two characters, right? But again, self-contextualization. I want the regex to be pretty easy to understand. In the second example, we've got an email address, and we know that @ and dot, that's always going to be consistent. Now, set up exclusions. So we've set up our anchors here. We want to do our extraction, and then we want to end the extraction with an exclusion. And I've got a typo in this data set. There should be a in parentheses right here. Same with the bottom one as well. Lastly, you're going to want to set boundaries on your quantifiers. So we're used to using pluses, stars, unlimited quantifiers because they're easy and they're fast. But sometimes that can be damaging to the regex engine. It can take a catastrophically amount of time. So we're going to want to finite this thought process a little bit. I mean, what's the likelihood of a normal email address being more than 64 characters? Pretty darn low. So iterate through it, test it, make sure it makes sense. Now obviously there's going to be some of those ridiculously long email addresses from those spam campaigns, but for our incident, 1 to 64 may be reasonable. Let me prove this to you. So I'm going through a data set here, and I'm just pulling out email, right? And I'm using a generic one, easy to understand, and here we go. It's extracted it, but it's extracted way too much. So I need to clarify this regular expression, right? So I'm going to add in some exclusions, but now I've got this timeout. If you haven't seen this website before, this is probably my favorite website for messing with regular expressions, regex101.com. You can change the type of engine you're working with. It's really, really effective. You can even save your extractions. Highly recommend it. So we got our exclusions in. We're pretty sure we're right, but it timed out. So let's add some limiters on there. Now we've added that 1 to 30, and it's completed. We also want to focus on the negative. So when you're iterating through your development of regular expressions, we tend to think of all the possible characters that we want to bring into this capture. This actually makes it really difficult to troubleshoot because your expressions get long, they get complicated, and then you have to think of all of those edge cases that just aren't in a normal instance. For example, how many people have a plus in their email address? You kind of do, because per the RFC, you're allowed to use a plus, and you're allowed to change whatever comes after the plus, and it should still go to the same mailbox. Google is one of the only email providers that actually takes advantage of that feature. And if you're not accounting for a rarely used character in email, you might miss it. But if you exclude characters that you know will never be part of the email address, such as white space, you're good to go. So let's walk through this one more time. So again, I'm trying to extract email addresses, and I'm getting too much. So I'm going to iterate through this to clean this up. So I know that I should not be capturing any backslashes, so that fixes the back end. It's pretty easy, and I haven't had to overly complicate my extraction to get this information. Now, when I scroll down even further, I see that I've actually got multiple email addresses, and I may need a few more exclusions, such as quotations, commas, square brackets. So I've added those in. Now, I'm going to, I don't have any limiters on here. I'm using that plus, which allows it to go an unlimited amount of time. And right now it's taking 1.21 seconds to complete with over 1 million steps. If I keep the same extraction, but I just add some limiters, it's now down to 192 milliseconds. So think finite. You're going to save yourself and your sim a lot of time. Now, this was Splunk-specific. For those of you who like to use Splunk, you may not have known that the RegEx command has a max_match field. So if you add that to your Splunk, you can actually get multi-value fields. Pretty nice, pretty handy. All right, so let me break this down. We've got our capture group, email. I've got the character class for the mailbox name. That's the section of the email before the @ sign. And these are all the characters that should never be a part of that, including the @ sign. And based on my data set, I've determined that there's no more than 30 characters. I've got my anchor, my @ sign. And again, an exclusion group for the backside, that domain name. And in this case, I already have a limiter up here, so I used a unlimited repeater at the end. Now, this is a weird Splunk thing. If you want to capture a backslash, you can't just escape it. You have to double escape it. So it's 4 backslashes. Weird, accept it, we'll move on. All right, some of the things that you may want to pay attention to. Catastrophic backtracking. Repeating a capturing group unintentionally. I'm not going to go into these, but I highly recommend reading into them. It's rare that you would run into this, but it's worth taking note of. So I recommend this website, regularexpressions.info. Now, one thing I will talk about is assuming that all of your results are going to be captured. So let's talk through some common use cases. Oftentimes my team has to go through HR requests where we need to assess what people have been doing on the web and whether or not it's a professional part of their job. So going through user activity, what does their search history look like? So, you know, in Splunk we're able to pull in URL activity, and this can be kind of burdensome to crawl through. Now, Splunk has some features that can automatically pull out the domain name, but what if you don't have that? What if you want to just distill down the domain name? So again, we've got our capture group. We've talked about this before. We've run the RegEx command, and we've distilled down all that data to now 136 unique domains that the users visited to. And maybe this person really likes to drink beer. I don't know. You know, we have beer buyers at Publix, so that might actually be part of their job. But another element is, what's the user's intent? And this one's kind of fun because this is where you get to see hands on keyboard. Can you demonstrate that the user was wanting to get to the data that they happen to see? Well, search history really, really helps. So it's a little hard to see here, but these are all Google results, and it's ridiculously long Google strings. So we start to bring in the information, and we use the Q equals as the anchor. run our search string, and we notice that the end of it, that ampersand, is that end anchor. So we exclude it, and we just bring in everything else. Splunk has a feature, URL decode. You don't really need it. And now I've got hands-on keyboard what the person was actively searching through Google. And depending on how your squid logs, your proxy logs are coming in, because of how Google is every keystroke presenting that and giving you search results back, you're going to get proxy logs for every single keystroke. And you're going to get, as the person's typing, what they're looking for. So Bing, this is an instance where we developed this query and we said, hey, we think we got everything. We tested it and we realized we did not get everything. So that's one of those pitfalls. Don't assume just because you're getting results that you're getting all the results. In this case, we had two different elements that Bing likes to use. So we have two different sets of anchors. We run the search string, run it again. And here you can actually see people hands on keyboard doing their favorite Bing search. Looking for Google. Words near other words. So this was something that I was playing with, and I almost scrapped it, and then my partner, who's not here today, my partner found a really good use for this. So we were trying to find instances for the word username near the word password. Because maybe we've got email logs, and maybe we want to see passwords in the clear. Or maybe we've got web application logs, and we want to see if that data is actually being transited in an unencrypted packet. So in this case, we were looking through SMTP logs, and we actually found an instance of K-Lagerfield's username and beer lulls. So a little easier to see here. So this is kind of a problem, and if this is a persistent problem, maybe we want to actually extract out the information so that we know what users we need to worry about doing the password reset on. So we worked through that. Hey, based on this email traffic, just username, password, extract the information, set our anchors, set our limiters, and here we actually have K. Lagerfield, beer lulls, and the extraction decoded. In a large-scale attack, this could be really, really useful. The previous talker in this room mentioned the scam that's going around. It's kind of old, but it's come right back around again. Hey, this is your username and I have your password, and I've seen all those dirty things you've done on the internet, right? I just got one in my Gmail the other day. I'm like, you have, I'm boring. I'm really boring at home. So good luck with that one. But if that type of scam is coming into your corporate internet, and those are actual passwords, which the one that hit my Gmail was an actual password from like 10 years ago, pretty sure it was from the Adobe breach, that may be something that you want to start digging through the logs to get this information, because if those passwords are still legit that your associates are using, you're going to need to go through the password resets. Now, Splunk has a feature that we wanted to highlight. You could actually do do masking, because maybe you don't want to actually give away the password in the logs that you submit up to management. So working around parsing errors. For those of you who love Splunk, will probably run into this quite a bit. Parsing errors can be the bane of an incident responder's experience. So we were doing some analysis on a sample data set that Splunk gave us, and we thought we had everything here. And we were a little confused. Why are there only 3 domains in this data set? So when we started digging in, we realized that no, we've got some other domains, and we should probably assess this fidelity of these logs a little more. So we did our extraction. Again, anchors, limiters. I added an HTTPS here for that self-contextualization. And now we're getting a lot more results, a lot more domains, no longer depending on potentially faulty automatic extractions. And in this case, one of the domains that got highlighted right away was this one, server.org/malware-download. This was in the middle of one of Splunk's sponsored CTFs. SQL injection. So, I'm assuming everybody here knows SQL injection. At the Splunk conference, we couldn't make that assumption. But the point of this is, you've got an alert, you're starting somewhere. Remember, this is post-alert. Now, in this case, we found that there was an attack against this this function being used, and an overload of that function was allowing a SQL query to be injected in order to dump information. So after the attacker submitted this, this was submitted back to the attacker, providing the username. So what we're trying to ask now here is, we've demonstrated, we see that there's a SQL injection attack. What is the scope of this attack? How many usernames? How many passwords? What else has been leaked out? So we do our extraction, we use that function as our anchor, and we use the angle bracket as the rear anchor. We pull everything else in just so we can start pulling in these SQL injections for analysis. So here we can see over and over and over the subsequent SQL injections that we have. So if you look closely, you can see they're pulling password, they're pulling salt, they're putting email addresses, pulling usernames. Okay, that's information we want to know. Well, what about the results that were sent back to the user? So let's start pulling that information. Now we've got the XPath syntax error as the anchor. And now we're seeing exactly what was given back to the attacker over here. We see both the query that was given and the results. And with a bit of fancy Splunk foo, we're able to table those results so we can see how everything was related together. So the password hash, the salt, the username, all of that jazz. So a SQL injection attack that you were vulnerable to, and now you need to know what you've disclosed, much easier to analyze. Now, you're not going to be able to use these regular expressions cut and paste. That's not the point of this talk, right? The point of this talk is just develop based on your data set as fast as you can. Cross-site scripting. Cross-site scripting is starting to go away. There's still definitely exposure on the internet, but simply it's a script embedded somewhere, either reflective or resident, and it injects code that wasn't supposed to be running. So, skipping past the Splunk-specific stuff, we had an alert on a cross-site scripting, and it was obviously malicious because that organization was never going to have Korean symbols. So the original analysis was to just look for the word alert and filter out alert.js because that was really, really common. And there were 3 results, and 2 of them were false positives. Okay, let's try the RegEx way. So this time we're looking for our anchors, and we're specifically looking for the script tag. Or in this case, I'm sorry, the code tag. Because the code tag is what was being taken advantage of for the cross-site scripting. So here's our RegEx, code equals, pull everything else. So in this case, we actually got more cross-site scripting hits that are true positives, just because we didn't assume that it required the word alert in the cross-site scripting attack. Now, granted, there's maybe non-RegEx ways to do this, but one of the things I like about regular expressions is that you end up naming your fields. And so with cross-site scripting, your field is now cross-site scripting. So a follow-on analyst knows what you're looking for and what you're anticipating in these results. Working with Sysmon. All right, who here has deployed Sysmon to their Windows environment? I highly recommend you deploy Sysmon to your Windows environment. If you're not looking at Windows event logs for threats, you should be, and Sysmon gives you so much more data than the natural Windows event logs. The problem is, it's not natively parsed by a lot of SIMs. Even though it's XML based, it's just not natively done, including with Splunk. So before we get here, one of the things that Sysmon is really valuable with is it'll give you a hash of the executables that are run as they're run. It'll give you the command line parameters of the executables as they're run. Some of this information may be available through amplified GPOs, but the hash isn't, and that hash can be really, really powerful. So we had a scenario, employees hiding his browsing history behind Tor. So what version of the Tor browser was downloaded? So we're working through Sysmon. Sysmon typically looks like this. I don't want to spend the time to parse Sysmon. I've got Splunk engineers who can get that fixed. They just got it on their roadmap. I need to deal with this incident today. And everything has a tag and a tag. Now, you should not be using regular expressions to parse XML. Do not do that. That is bad. It is never going to work successfully. But you can use regular expressions to parse the information you need in order to get what you want. In this case, we're just looking for, we know there's going to be a tag, and we know that there's going to be the word file and Tor either uppercase or lowercase. So let's pull that information out. And quickly we can see command line, current directory, image, parent command line. These are fields that have been related to the word Tor in the Sysmon data. I've been able to take all of that Sysmon data, which is a lot, and distill it down to 6 total categories with about 200 events. So digging down even further, now I can actually see what was being parsed through Tor. Awesome. Now, if you're an Elk Stack user, you can do this in Elk Stack as well. I am by no means selling Splunk. If you're pulling the raw logs, you can do this in Notepad++. I'm by no means selling Splunk. It's just what I'm comfortable with. So, any questions so far? Yes, sir.
You highlighted real quick, I was playing Door Duty, so I apologize, the Splunk RegEx multi-value field.
Yes, sir.
Elaborate on that a little bit.
Absolutely. So let me hit, I think that was slide 14. Okay, so the key element here is your regular expression. If you just use natural regular expressions, it's going, I forget the term, whether greedy or ungreedy, I always get those confused. But it's going to naturally pull all the results. That's the way just Splunk happens to do it. You can change that parameter if you really want to, but it's going to pull more than one. It just will only return the first result unless you set a max_match parameter. So if you set it equal to 0, it'll pull in all the results and put it in a multi-value field. The multi-value field looking like this. Here's one event, and here's all the email addresses that were in that one event from that single regular expression.
So
max_match equals 0. Anybody else? Well, as I typically do, I talked way too fast. So that is my presentation. Thank you so much for attending. I appreciate it.